Proof of stake versus proof of work versus proof of time. What's the difference? Consensus algorithms are the protocols that govern how a blockchain is secured and how transactions are validated within the network. Proof of work is an algorithm that requires computing power to solve complex puzzles, and proof of stake is known for its token staking system, while proof of time is an algorithm that looks at a user's reputation and time within the network, amongst other factors. In this video we'll look at the difference between these three algorithms and how they compare. Proof of stake. Proof of stake is a mining algorithm and consensus mechanism that relies on nodes within the network staking their tokens to secure the blockchain and validate transactions. Proof of stake works by incentivizing nodes, computers that downloaded a copy of the blockchain, to stake their tokens with a chance of being chosen to verify the next block. This is because each block contains several transactions, and nodes with larger stakes are more likely to be chosen to validate the next block. If a node is chosen to validate a block of transactions, they are rewarded with additional tokens. However, if a node has been caught acting maliciously, it will lose the tokens they have staked. Proof of work. Proof of work is a mining algorithm and consensus mechanism that relies on a miner's computing power to secure the network and validate transactions. Proof of work was the first mining algorithm used to secure the Bitcoin network and was the initial algorithm used by Ethereum before they switched to proof of stake. Proof of work uses a miner's computing power to solve complex mathematical problems, with multiple miners competing to solve them. The more computing power a miner has, the better their chance of solving the puzzle. The successful miner gets to validate the next block of transactions and receive bitcoins as a reward. However, if the miner is caught acting maliciously, they won't be able to validate the block, meaning their computing power has been wasted. The mining difficulty for proof of work also changes based on the number of miners on the network. In Bitcoin's early days, anyone could mine BTC using a laptop or computer. However, nowadays, Bitcoin mining requires multiple dedicated graphics cards to provide the computing power needed for the proof of work protocol. This is due to the many miners on the Bitcoin network today. Proof of time. Proof of time is a consensus protocol that looks at a node's reputation and time within the network. Analog developed the algorithm, and nodes have to be voted in before they can validate any transactions. Whereas most consensus algorithms work within blockchains, the proof of time algorithm uses a time chain. Network validators are chosen via a ranking system that assigns a score to a node based on their previous actions and time within the network. The node stake tokens are also taken into account during this process. The longer a node operates within the time chain, the more trustworthy it is and the better its chance of being selected. Once a node is selected, it confirms the transactions, generates a VDF proof, and submits the data to the other nodes within the network. 1,000 time electors then double-check the data, and if they agree to accept the transaction, it is added to the network. How the algorithms compare. Proof of stake differs from proof of work and proof of time since a user's stake is the main determining factor in being chosen to validate the next block. When choosing a node, the protocol does not rely on a validator's energy expenditure, its time within the network, or reputation. Instead, multiple nodes decide who can validate the next block of transactions by randomly selecting from a pool of nodes. Nodes with larger stakes are more likely to be selected in this process. Proof of work differs from proof of stake and proof of time since energy use is the determining factor when selecting a miner to validate the next block of transactions. The more energy a miner uses, the better chance they have of solving the mathematical puzzle and being chosen to mine the next block. As mentioned earlier, mining requires physical hardware, and popular networks like Bitcoin require users to invest in expensive hardware to gain a chance at being selected. Proof of time differs from proof of stake and proof of work since it considers a node's reputation and time within the network to determine who gets to validate the next block. Nodes are more likely to be selected if they have been active for a long time and have good reputations. A verifiable delay function, or VDF, is used to randomly select nodes while considering the node's ranking score. Proof of time does share some similarities with proof of stake since nodes are required to deposit or stake tokens. However, nodes within the time chain use a fixed stake system where every node deposits an equal amount of tokens to be staked. This system is set up to make the process fairer since priority is not given to a node based on the number of staked tokens. Instead, a node's reputation and time in the network are valued more, and the selection process is still randomized. Conclusion. Proof of stake is a consensus algorithm that selects nodes based on their staked tokens, with larger stakes improving their chances of being selected. Proof of work relies on a miner's energy output to secure the network, and the more energy a miner uses, the better chances they have of being selected. Proof of time considers a user's reputation, ranking score, and time within the network when selecting a node to validate transactions. The protocol also uses a fixed stake mechanism, so nodes are not selected based on how many tokens they have staked. Instead, once a node is selected, they validate the transactions, generate a VDF proof, and send it to other nodes to be double-checked before being added to the time chain.